this topic is no longer on paper 1, would only be examined on paper 2. For the first answer, the answer is gravitational potential energy. So the water in the upper lake, it has gravitational potential energy because of its height, and then as the water flows down the tunnel, that gravitational potential energy turns into kinetic energy, which then turns the turbine, becomes the kinetic energy of the turbine. That leads into the second part, which is less about energy transfers and more about electromagnetism, because there are 5 marks that you can get here, of which you only need to get 3. Only one of the marks is to do with the turbine. So the first possible mark is just that the turbine spins. You can get a mark for that. The other 4 marks are for describing how the generator actually turns that kinetic energy into electrical energy. So with a generator, what you have is that you have your either fixed magnet or your electromagnet, and that within that you have coils of wire that turn. So first mark you can get is that the coil of wire spins between the poles of a large or a strong or some kind of strong magnet. Doesn't need to be an electromagnet. The third mark is that when that happens, current or voltage is induced. So it links to that electromagnetic induction rather than energy transfer in or across the coils of the wire. Suggests why it's important that the turbine turns at a constant speed. The speed controls the current or the voltage that is being produced. So your first mark is for linking speed with either current or voltage. And then the second mark is easy, but probably some people will miss it because it's too obvious, that you actually want a constant current or voltage to be produced. Then it's back to energy transfers. So we've got a Sankey diagram here. State the relationship between efficiency, useful energy output and total energy input. That's just writing down the equation. So it's efficiency equals useful energy output over total energy input. Obviously you write that out in words properly. And then the next part is to actually use that equation. Now it wants the total wasted energy. Now be careful here. So this is why this is a 4-mark question, because you've got more than one step. So the first thing you have to do is work out your useful energy output. So you've been given your efficiency, which is 36%. When you put that into the equation, you're going to put it in as 0.36. Then your useful energy output is what you're trying to find, first step. And your total energy input is 1050. So when you rearrange that, you get that your output energy is 378 kilojoules. Again, you can, because it's in kilojoules, you can switch it, but then you want your answer in kilojoules anyway, so there's not much point. Then you haven't quite finished, because this is your useful output. So your wasted energy is going to be your total input, take away your useful energy. So if you take those 2 things away, you get 672. And then naming 2 forms of wasted energy. Any questions about wasted energy, the chances are it's going to be heat and sound. But it's not enough just to say heat and sound. You have to say where that energy is going. So for example, answers here could be heat energy in the water, or thermal energy in the water. You could have thermal energy because of friction through the pipes, water travelling through the pipes. You could have heat energy due to friction because of the spinning of the coil. So it's always going to be something to do with heat and sound or friction, but you've got to be specific.